Let's study coplanar vectors. Coplanar vector means those vectors which lie in the same plane in a 3D space. Okay, vectors lying in the same plane. We can write here. So here we see vectors lying in the same plane. Okay, same plane in a 3D space. What is a 3D space? So let us let me give you one example. Suppose it is vector A and this is, let it be vector B, let it be any vector C. Okay, these are three vectors. Okay, these are lying in a plane, lying in the same plane. And what is the plane? In which plane these three vectors A, B, C are lying? The plane is this. This paper is the plane. This paper. Okay, this paper is a plane here, and this, and on this plane these all three vectors are drawn. Okay, and what is 3D space here? 3D space means what? Three-dimensional. 3D and a space are both the same things. A space means three-dimensional. Three-dimensional is what? Length, breadth and height. X coordinate, Y coordinate and Z coordinate. Okay, this all atmosphere, this copy including this environment, this is the 3D space, and these all the three vectors are lying in this 3D space. Okay, this plane is even lying in this 3D space. Okay, so these vectors are also lying in the 3D space. Okay, vectors are lying in the plane and plane is lying in the 3D space. Simple. Okay, now we understand coplanar vectors. Let me elaborate some more examples. Suppose this one. This is a pen cap. Okay, and we applied some force in this way. Okay, we applied some force in this way. This is one experiment. The pen cap was here and we applied some force in this way and it moved in this way. Okay, by the force, by some force is a vector, we know that direction was here, and again another time the cap is here, and instead of moving in this way, what I did, this is upward move. Let I gave it upward move. Upward means it is not going in this way, it is going upward. Okay, upward means it is leaving the plane of paper, it is leaving this paper, so it is moving upward. The paper is left. Okay, the plane of paper is left, means then in this situation the two forces are not coplanar. The two forces, the two vectors are not coplanar because they are not lying in the same plane. This force is lying on the plane of paper, but when we throw it upward, it is not lying in the same plane as previously. Okay, so this experiment clarifies what is a coplanar vector. Okay, now let's see what is the condition for being coplanar. What can be the conditions? This is the defining part and this is now condition. How can we say, when can we say the vectors are coplanar? Will be shown by the condition. When the scalar triple product, a scalar triple product equals to 0, then the vectors are coplanar. Okay, a scalar triple product means vector A dot vector B cross vector C, this is 0. Okay, a scalar triple product, we know it is vector A dot B cross C. This is the term for scalar triple product, and this should be 0 for three vectors A, vector B, vector C. The scalar triple product will be 0, then only the vectors are coplanar, means they are lying in the same plane. Actually this scalar triple product is what? This is volume of parallelopiped. This is volume of a parallelopiped. This is volume of parallelopiped is somewhat like this figure. Okay, parallelopiped has some base, it is, and some height also. Okay, some height and some base. Okay, when this is volume of parallelopiped, when the volume of parallelopiped is 0, it means what? Its base is here and it has some volume, means height, sorry, there is a base and there is a height in parallelopiped, and when the height will be 0, if height is equals to 0, then the volume will be 0. This implies that volume will be 0. Okay, if height will be 0, if height will even tend to be 0, the volume will be 0. Okay, if the height will tend to be 0, what will remain? This plane only remain. Okay, so if a scalar triple product, that is volume of a parallelopiped, is 0, the vectors are lying in the same plane. Okay, Because volume is 0, it means height is 0, it means tending towards 0, it means only one surface remains. This complete set of surfaces make the volume. Okay, suppose that how can I elaborate? This is a pen. Sorry, this take it. This is a cap. This is like a parallelepiped. Suppose it is a parallelepiped. Okay, it's when its volume is 0, it means its height is 0. When the height is nearly 0, okay, then what will happen? This surface will, its base will remain, and its base will lie out at this plane of paper. Okay, this height is made up of what? One plane, two plane, three, numerous planes. Okay, kept seat by seat, numerous planes, and these all planes make it a height, numeric height. And when this height will be tending towards 0, then we can assume that a single plane is left, because the width of a plane tends towards 0. Okay, so we can assume a single plane is left. So if height is 0, we can assume the vectors are lying in the same plane, that is at the base of the parallelepiped, and the base of the parallelepiped is a plane. Okay, so it is coplanar when the scalar triple product is 0. Okay, let us see one example. Here is a question. Show that the vectors vector A, vector B, and vector C are coplanar. We have to prove the given vectors are this. Vector A is, these are three given vectors. Okay, and to show the vectors are to be coplanar, what is the condition? The condition is A dot vector B cross C, that is a scalar triple product should be 0. This is the condition we know. The scalar triple product should be 0. So vectors are given. Vector A, vector B, vector C are given. Now let's find the scalar triple product. How you find it? The scalar triple product. For finding it, the scalar, we find the determinant. Okay. The determinant of, how we find the determinant? We arrange it -4. This is mathematics. After this, it is simply mathematics. We have to solve the scalar triple product, and then numeric value will be 0. Then it is proved. Okay. So let us solve. -4, -6, -2, -1 it is. Then it is 4. Then this one 3. This one -8, -1 plus 3. This, that is, we can write A dot B cross C. This equals to, that is -4, 4 into 3. This is -1 into 3. This is -6. Simply, if you will solve this thing, this is a simplification of class 5 or 6. You can solve it easily. The result will be 0. Okay, the result comes to be 0. So we can write A dot B cross C equals to 0. So it is proved. Okay, thank you.